Welcome back and thanks for joining me again for another video from the Math Doc. This set of videos will focus on algebraic inequalities, and in this first one we'll really focus on the question, what is an algebraic inequality? And we're going to start off by reminding ourselves what an actual equality is. So if you're new to this channel and you haven't checked out the equality section, please check out that playlist because it will help you with background to this set of videos on inequalities. So what is an inequality? Well, let's start with equalities. So for instance, we know that 5 minus 3 equals 2. This is an equality, right? Not an inequality, but an equality, right? Because 5 minus 3 equals, okay, comes from the word equals 2. So that is an equality. So what is an inequality? Well, an inequality would be to say either that 5 minus 3 does not equal 7, for instance, but it would be something like 5 is less than 7. Okay, that is an inequality because we're using the less than symbol. So let's start really by looking at the number line. We'll start with simple cases and we'll build from there. So if this is the number line and we have 0, 1, 2, 3, 4, 5, 6, we know that 5 is larger than 3, right? We know that 2 is less than 4. We even know that 5 minus 1, which is 4, is less than 6, right? So we know all these inequalities hold true from just counting things, right? We know what is less and what is more or larger and when we look at numbers. So let's look at another number line, and now let's graph an inequality, okay? So let's graph this inequality. I'm going to fill in a circle at 3 and show an arrow going towards plus infinity, right? So what this graphing of an inequality is that x is larger or equal to 3. The larger or equal symbol, larger or equal, shows up in this graph as this full circle here. So it can be equal to 3 because of the full circle, but we know it can take any value upwards of 3. What if we have an open circle at 1 and an arrow pointing towards the negative numbers, okay? Downward, towards smaller numbers? Then we know that x can be less than 1. And why less than and not less than equal? Because I left this circle here empty. So when we have an empty circle, we're looking at an inequality that does not include the end point or the boundary point. Does not include endpoint. While the full circle does include the endpoint. So by looking at these graphs, we can write down an inequality, and we can go back and forth between these two presentations. We can write the inequalities as in the form of an mathematical inequality like that, x larger than 3, or we can graph it, and both will mean the same thing. Okay, both this graph and this mathematical expression mean the same thing. Now, what happens when we have a real world problem? For instance, what if I tell you that in Los Angeles, the temperature never goes below freezing. Okay, so it never goes below freezing point. So in Los Angeles, we never get frost or snow. How do we graph that? Well, let's look at the number line, and let's do it in Fahrenheit. The freezing point in Fahrenheit is 32 degrees. So this is degrees Fahrenheit, right? So we have 32, 33, 34. Here we have 31 and 30. But what we know is that the temperature never goes below the freezing point. So it's above or equal to 32 degrees. And we can draw that. We can graph it. Let's use a different color maybe. We can graph that just like that, right? We can also write it in terms of an inequality as a mathematical expression. So we can write the temperature, let's write that as T is always larger or equal to 32 degrees Fahrenheit in Los Angeles. So we've taken this real world problem and we've graphed it here, and we've also written it out as a mathematical expression. Let's look at another quick example. For instance, the price of gasoline has not gone below $2.50 in the last 10 years. That's true at least for Los Angeles. Can we write this out as an expression, as a mathematical expression? Yeah. Let's write the price as P. P is larger or equal to $2.50. And on the number line, if we have 0, 1, 2, 3, we can write that right here. 250 is just in the middle. Again, let's switch colors so that it's clear. Right? So the price of gasoline is always above $2.50. What else can we say? Well, we can look at an example of something that is always smaller than something. Let's look at another temperature example. We can say that the temperature of water in its fluid form will not go above 100 degrees Celsius, the temperature at which it boils, right? So we know that if we want water in its fluid form, it will never go above 100 degrees Celsius, otherwise it will turn into vapor. So again, we can do this in terms of a graphing problem, where here I'm going up to high temperatures. The temperature of water cannot go above 100 degrees, so it has to be below or equal to 100 degrees, and we can write that out as a mathematical expression that the temperature of water is always less or equal to 100 degrees Celsius. Okay, so these were some quick examples of what an inequality is, and in the next few videos we will get deeper into that. We'll learn how to solve inequalities and all those good things. So thanks again for joining me. If this video was helpful, please like. If you have questions, please include those in the comments, and I look forward to seeing you again in our next video.